Hello, welcome to the second part of our lesson on network devices. This is the first lesson from the first module of my new course on networking fundamentals. The purpose of this module is to teach you how data flows through the internet. In part 1 of this lesson, we discussed the concepts of a host, an IP address, and a network. If you haven't watched that video, go ahead and pause this video right now and watch the first video. There'll be a link in the description. In this video, we're simply going to continue right where we left off. Now, the main idea we want to teach in this video are these last two devices, switches and routers. But we can't really understand those until we understand where we've come from, so we have to start there. In the last video, we unpacked the idea of a network. We identified that a network is created anytime you connect two computers to each other using a wire. One thing to understand about sending data across a wire is that it decays as it travels greater and greater distances. If the two computers you're connecting are in the same room, then you don't really have to worry about it. The decay will still occur, but the signal will still get through, and therefore connectivity between these hosts is still attained. If, however, these hosts span greater distances, maybe you're connecting two computers on opposite sides of a building, or even in two different buildings, then you might have a problem. If the signal decays before it gets to the other side, then these two hosts cannot share data. In those cases, what you need is a repeater. A repeater is a device whose sole purpose is to regenerate signals. Anything that comes in on one end simply gets regenerated out the other side. This allows you to connect devices together which span greater distances. So far, we've been talking about networking from the perspective of connecting one host directly to another host. Well, if you add a third host, you now have to connect that host to all the other hosts which you've already established. And if you add a fourth host, you now have to connect this fourth host to all the hosts that already exist. And again, if you add a fifth host, you now have to connect this fifth host to every host that has already been connected. As you can see, connecting hosts directly to each other simply doesn't scale. Instead, we created devices which we could put at the center of every network and connect all the hosts to those devices. And these devices would then handle funneling communication between these different hosts. The benefit to these types of devices is that if a sixth host gets spun up, it's very easy to simply connect it once to that device, and now it has connectivity to every host that has already existed. That's what all of these are. And the first of these types of device that we're going to discuss is known as a hub. A hub is nothing more than a multi-port repeater. Earlier, we discussed repeaters, and we said all they do is regenerate signals. Well, hubs do the same thing, except they do it across multiple ports. For example, if these two hosts over here need to communicate, when one of them sends a packet to the other, it'll hit the hub, and the hub will simply duplicate that packet and send it out all remaining ports. That'll allow what this guy sends to arrive over here. This fixes the scale problem. A hub is the first device that allows us to connect multiple devices in the center, and now all of them have connectivity to each other. But as you can probably see, the problem with a hub is that everybody receives everybody else's data. These two hosts over here, which are uninvolved in the communication between these two hosts, are receiving a copy of everything they send. Which brings us to bridges. Here we have two sets of hosts, all interconnected using a hub. And a bridge is meant to sit in between hub-connected hosts. Bridges, by definition, only have two ports. One port facing one set of hub-connected devices and another port facing the other set of hub-connected devices. Bridges will also then learn which hosts are on which side of the bridge. This will allow the bridge to contain communication to only the side that is necessary. For example, if these hosts again need to speak to each other, when they send data to each other through that hub, the hub is of course going to simply regenerate that signal out all ports. And notice that the bridge is going to be getting a copy of that packet. But the bridge knows that the other green host is on this side of the bridge, and therefore the bridge isn't going to bring that packet to the other side. The bridge is the first type of device that helps contain packets only to their relative networks. On the other side, if these hosts need to speak to each other, they can also send packets to each other through their hub, and once again, the bridge will not let those packets bleed into the other side because it knows the yellow devices exist on the right hub. And of course, if this device needs to send something to this device, the bridge is going to know that that traffic is going to have to cross the bridge, and the bridge will allow that packet to traverse to the other side. The main takeaway is understanding that bridges can learn which hosts are connected on either side of the two ports of the bridge. Now this finally brings us to switches. Switches are sort of like a combination of hubs and bridges. They are like hubs in the sense that many devices can connect to the switch, and they are like bridges in the sense that they can learn which hosts are connected to each port. The main difference is that they're doing it on a per port basis, which means if these two hosts want to speak to each other, the switch will know that the only ports that need to receive this traffic are the two that are connected to those green hosts, and will keep that communication contained to just those ports. Moreover, if these two hosts want to speak to each other, the switch will again make sure that that communication only flows between the relative ports. So this is how a switch is like a combination of a hub and a bridge. The formal definition of a switch that we want to use is that a switch is a device which facilitates communication within a network. Earlier, we defined a network as a logical grouping of hosts which require similar connectivity, which means all of these devices over here all belong to the same network. Moreover, networks all share the same IP address space, which means this network owns all the IP addresses which start with 192.168.1.anything. And this host's identity is the IP address 192.168.1.33. And this host would be 192.168.1.66. And this set of devices could very easily represent all the different hosts on your home Wi-Fi network. Maybe this device is your printer, and this device is your laptop, and this device is your mobile phone, and so on. Or maybe this network and these devices represent all the PCs that might exist within a particular classroom of the school network. Or maybe, even further, all of these devices represent hosts that exist in the sales team of the London office of the Acme Corporation. One way or another, since all these devices are connected with a switch, they all belong to the same network. Now, let's go back to that example of the school network. We said that the school likely has many different classrooms, and each of those classrooms belong to their own network, which means this would be a more accurate representation of the school network. We would have classroom 2 owning that IP space and classroom 3 owning that IP space. Now, the reason you might want to separate these two sets of devices into their own network is because they might have different connectivity requirements. For example, maybe these computers over here all belong to the biology classroom, and all they need is simple internet connectivity. But maybe these computers over here belong to the computer science classroom, and they not only need internet connectivity, but also access to various cloud resources to do their studies. Well, since these computers have different connectivity requirements than these computers, it's a good idea to separate those out into separate networks. Now, in both cases, we can still use switches to facilitate all the communication within the networks, meaning this switch can handle all the communication between these three hosts, and this switch can handle all the communication between these three hosts. But what happens if this host down here wants to speak to this host on a different network? Well, if a switch can only facilitate communication within a network, we would need another type of device to handle the communication between networks. And that device would be a router. A router is a device whose primary purpose is to facilitate communication between networks. At the very least, you're going to need that router to connect you with the ultimate network of networks known as the Internet. So let's unpack this further. Routers provide traffic control points between networks. Let's say we wanted to limit the traffic that could go from this PC to this PC. Well, since these two PCs aren't separate networks, all that traffic has to flow through the router, creating a great place to add security policies or traffic filtering, or even redirecting that traffic elsewhere entirely. Since routers sit on the boundary between networks, they provide a logical location to apply security policies. This type of security filtering isn't traditionally available on switches. These days, there are modern switches that can do such filtering, but it is generally accepted that the devices sitting on the same network don't typically need filtering for traffic traveling within the network. If you had devices that needed different types of connectivity, you'd want to place them in different networks. The network boundary is what it's meant to be, the logical separation of devices. The way routers work is that they learn which networks that they are attached to, meaning this router is going to learn that on this interface it's connected to the 172.16.20 network, and on this interface it's connected to the 172.16.30 network, and out here is the direction to go to the internet. The knowledge of each of these different networks is known as a route, and all these routes are stored in what the router calls a routing table. A routing table is therefore all the networks that a router knows about, and the router is going to use this routing table in order to funnel traffic out the appropriate interface. Now, when we say a router learns which networks they are attached to, what we mean is that a router has an IP address in every network that they are attached to. For example, when this router is attached to this network, it is given an IP address in that network. This interface's identity is the IP address 172.16.20.1, and this interface's identity is the IP address 172.16.30.254. This IP address is going to serve as what's known as a gateway. A gateway is a host's way out of their local network. For example, this host over here has the IP address 172.16.20.33. But if that host wants to speak to something on a different network, it knows it's going to have to go through a router. And the IP address of that router is stored as that host's default gateway. Notice this host has a default gateway of 172.16.20.1. That's this interface IP address of that router. Now, if we go a step higher than that, routers are actually what create the hierarchy in networks and IP addresses that we discussed in the prior sections of this lesson. For example, the New York office of the Acme Corporation that had all the different teams that each had their own IP networks, well, each of those networks are connected to different routers, and each of those routers are then connected to another router. And if a host in the sales team wants to speak to a host on the marketing team, it's going to use its gateway, which is its closest router IP address, which is then going to send the packet to the next router, and then finally to the host on the marketing team. The Tokyo office of the Acme Corporation is likely going to have a similar setup, and both of these routers are then likely going to connect to the internet. The internet is nothing more than a bunch of different routers itself, meaning if a host on the marketing team wants to speak to a host on the engineering team in Tokyo, that host will send the data to the router, which will send the data to the next router, which will send it through all the routers on the internet, which will finally send it to the Tokyo router, and finally to the engineering team. And that is how data is going to flow across the internet. And that is the role that routers play in making that possible. Now, the last idea I want to leave you with actually involves pulling back the definition of switches as well. There's something important you have to understand about what we've defined as routers and switches. Routing is the process of moving data between networks. A router, as we have described it, is simply a device whose primary purpose is to perform routing. In the same way, switching is the process of moving data within networks. And a switch, as we have described it, is a device whose primary purpose is switching. The reason I bring that up is there are many other types of network devices that exist out there. Access points, firewalls, load balancers, layer 3 switches, proxies, and there's even devices that only exist in the cloud, like virtual switches and virtual routers. One way or another, all of these devices are going to perform routing or switching or both. So later on in this module, when we describe what a router does or what a switch does, what we are actually describing is what any device does that implements routing or any device does that implements switching. And with that, we close our lesson on network devices. In part 1 of this lesson, we unpacked hosts, IP addresses, and networks. And in part 2, we continued that discussion by illustrating repeaters, hubs, bridges, switches, and routers. In the next lesson, we're going to give you a practical perspective on the OSI model. This will lay the foundation to understand what all of these devices do to enable data flowing through the internet. But that wraps up this lesson. Your main takeaways are on the slide right now. I hope you enjoyed this lesson. I want to thank you for watching, and we'll see you in the next one. Hey YouTube, I hope you enjoyed that free lesson for my new course on networking fundamentals. I'll be releasing the entire first module for free here on YouTube. I want this course to be the ultimate networking fundamentals course, and since I'm still scoping out the outline, you could have a say in what topics will be covered. Let me know in the comments below what subjects you want included in this course. Otherwise, remember to like and subscribe. And of course, if you learned something from this video, the best way to thank me is to share this video. It's a small act of gratitude, but one I appreciate greatly. I hope you enjoyed this lesson. I want to thank you for watching, and we'll see you in the next one.